Hey guys, this is just a little video to summarize when you've got a neutralization reaction, you got an acid reacting with a base. There are different types of problems that you can encounter. It's based on just a few things. You need to look to see if the acid is strong or the base is strong, see if they're both strong, see if one's strong and the other is weak, and then you have to look at which is in excess. We usually do that with the Chewbacca table, but the BCA table. So let's just go through a quick outline though. So if you've got a strong acid in excess, regardless of what the other thing is, right, you're just going to use that concentration of what remains after the neutralization to find the pH, right? So it's the negative log of whatever's left. If you have a strong base, you're going to do the same thing. If it's in excess, regardless of what the acid is, whether it's strong or weak, you're going to take that excess, what's left over, and you're going to use that to find the pOH, and then you're going to use that to find the pH. So pretty straightforward on both of those. Now, when you have equal amounts of strong acid and strong base, that's going to completely neutralize. It's going to make a pH of 7. Remember that the conjugates are so weak that they don't affect the pH. That's what makes it a strong acid, is that they have such weak conjugates. So they're not going to affect the pH. It also, if you have equal amounts of a strong acid, strong base, neutralization, complete neutralization occurs, and you end up with a pH of 7. So if you've got an equal amount of acid and base, and one of them is strong and one is weak, then you get a complete neutralization, but whatever the conjugate is of whatever was weak. So if you've got, let's say you've got a weak acid like acetic acid, then the acetate is going to work as a conjugate base, and that's going to affect the pH. It's going to make it a little higher than 7. So you're going to have to make an ice table so you can figure out the pH based on that. If you have excess of the weak, whether it be acid or base, that neutralization causes the production of the conjugate. So now you've got, let's say it's an acid. You got a weak acid and you got its weak conjugate, or you've got a weak base and its conjugate acid. So in that case, you're going to use David Hasselhoff, right? And that, of course, is the pH equals pKa. So it matters what's in excess. So in excess, right? If it's a strong acid, if it's a strong base, we've covered that. If they're equal, right, then if they're both strong, then it's 7. pH is 7. Strong and weak, then you need to use the conjugate, use an ice table for the conjugate of the weak. And that's a little bit weird, but if you go back, we did some of those problems. It was before all this happened. And then if you have in excess weak acid or weak base, it doesn't matter, but I'll just say weak acid. Then you're going to do, right, you can make a buffer. And if that's a buffer, then you're going to use Henderson-Hasselbalch, David Hasselhoff. Same thing with a weak base. You might have to do some converting. You might have to turn the Kb into the Ka, find the Ka. Remember, Kw equals Ka times Kb. So you're just going to take Kw, 1 times 10 to the negative 14th, and divide that by your Kb to find your Ka of the conjugate acid. But it's the same thing. You're getting a buffer, and you're going to use that and Henderson-Hasselbalch. Right, so hopefully that kind of summarizes it all. So hopefully that helps you sort that out. If you have questions, as always, shoot me an email. I'm dying to hear from you guys. We just found out, it was just announced by the governor that we're not going back to school at all this year. So I'm pretty bummed. Be great to hear from you. Just ask any questions, whatever. I'm here to help. Miss you guys a lot, and I'll talk to you later.